Okay, let's see if we can do Lab 6 here virtually. So I have Lab 6 instructions here. For apparatus, we need 4 different resistors, or 4 resistors, 2 that have the same color coding, 2 with different wires, alligator clips, 2 multimeters, power supply, and grid. So we've got our 2 multimeters, we've got a power supply, we've got a bulb, an LED, although were those on the list? Those are for the next part. And we got several different resistors here. And we also need a breadboard. Didn't say that, but we have a breadboard here as well. A couple of breadboards here as well. So, first part says finding the resistance of the resistors. And so it wants us to carefully keep track of the resistors. And so the back page of the assignment has this grid on it. And this is where we're going to kind of store our resistors so we can keep track of which one is which and record information about them. And so the first thing it wants to know is the color bands. All right, so we got to look at the resistors themselves, and they tell us. We could just look at the colors if we can understand what they say. What kind of resistance the resistor has. So let's see if I can get this where you can see it. All right, so I just made a little picture here, and so we have some different resistors. I have a blue one here. It's a little hard to see, and a tan one. We don't have any of those in the lab, but you can see that they have different number of stripes. The tan one has only 4, whereas the blue one has 5. And the ones we have in the lab are like these, and they have 5 also, but they're a little bit different 5. And so, in general, there'll be some that have different colors, like this, color bands, and then there'll be 2 bands or 1 band that is a silver and gold color. So the silver and gold colors are not number colors. They're talking about the tolerance of the numbers that we have. And so it's within a certain tolerance of what it says it is. And so, for example, on this brown one, I don't know if you can see, but their colors over here, and there's a silver band on this side. So we're going to orient them when we try to read our colors, orient them so that the silver or gold tolerance bands are on the right. Something like this for these. And then when we read these, however many colors we have, so on the ones that we're going to be looking at, we have just 3 colored bands and then the tolerance bands. And so 3 different colors means we have 2 significant figures and then an exponent, right? So for example, if we had a resistor that was this, like this, red, purple, blue, and then 2 silvers, we would, again, looking at the lab, we have this list of a color coding list, right? So if we have red is 2, or 10 to the 2. Red is 2, basically. And so we would put a 2 here. Let's get something to write with here. So the first one is 2. The next band is purple. Looking over here at purple. Purple, violet is 7. So we have 27. So our resistor is 27 times 10 to the whatever blue is, right? So the first 2 digits, the first 2 bands are the significant figures, and then the last one is the exponent of 10, the power of 10. So blue, looking at our chart here, blue, where's blue? Blue is 6, 10 to the 6th. All right, so we have this resistor, if there was such a resistor, it would be 27 times 10 to the 6th, or 27 mega ohm resistor. All right. Tolerance, if that's a silver, looking at silver, it says 10%, and so it's 27 mega ohms plus or minus 10%, right? So it's within a range. They don't guarantee it's exactly that. If it was a gold band, it would be a little bit better resistor, and it would only vary within 5%. Okay, this last band is a temperature coefficient, and we're just not going to worry about that for today. So we're just going to kind of pretend like there are only 4 color bands for looking at our resistors. Okay, so it says we want 2 resistors that are the same and 2 that are different. Let me see if I can get stuff in here. Okay, and so we have a variety of resistors here, and it's a little bit hard to see, but I'm going to pick out, there are some that have, looks like brown, black, brown, a couple of those that match. This one has some orange, it looks like. This one has like red and purple. Let's go with those guys. Okay. Put these other ones to the side. And so let's just call these guys 4 and 5, and these, we'll do them like that. 1, 2, 3, 4, 5. Okay, and so get ready to write on your notes here. So looking at this one, let me hit the autofocus so that it comes into focus better. I think it'll do it somewhat better. All right, so I've got it backwards because the gold and silver are on this side, and I want them to be on the right, so let's turn around. Let's try the autofocus again, if I can hold still better. Okay, and so hopefully you can see it looks like red, purple, brown, silver, gold. All right, so we'd write for resistor number 1, red, silver, brown, silver. That's not right. Red, purple. What am I saying? Silver. Red, purple. All right. Good thing you're the scribe because I'm really messy. Red, purple, brown, silver, gold. All right, so red, purple. Oh, that's just what I had here. So red, purple is 27. So tolerance band color is silver. Expected resistance is red, purple, which is 27. But then brown, what is brown? Brown is 1, 10 to the 1. So 10 to the 1 is just 10. So 27 times 10. So we would expect this to be a 270 ohm resistor. Okay, we'll see in a minute. Let's do resistor number 2. Okay, it's backwards again. We want gold and silver on the right. Gold and silver on the right. If I could hold it in the focus area. Hopefully you can kind of see. It looks like orange, orange, brown to me. Orange, orange, brown. So see what you get for orange, orange, brown. So all of these resistors I took out of drawers that said they were in the range of from 40 to 500, like the instructions say. So hopefully we get something in that range. Let's look at resistor number 3. I've already lined it up with the silver and gold on the right. Looks like brown, black, brown for that one. And then this one should also be a brown, black, brown. So this is resistor number 4. Brown, black, brown. Okay, so I've got them in their little spots on the, you can't really see them, but the little spots. Let me get the autofocus back onto the table kind of layer. So I've got the resistors in their little spots. You should fill in the color codes, fill in the tolerance band, fill in the expected resistance for all those, right? You're the scribe. All right, so the next part says measure these resistances with your DMM. So that's always a smart thing to do because sometimes it's hard to see those colors. And anyway, and it's good to know the exact value better than plus or minus 10%, right? Oh, all of these have silver for the tolerance, by the way. All right, so we're going to put this meter over here that's got the R little node piece on there. And we're going to go to ohms, and I'm just going to put it on 2K ohms. Lost my little thingies. 2K ohms as a maximum setting because I think all these they're supposed to be in the range of 40 to 500. So that should be a good setting. All right, so let's measure resistor number 1. I've got my alligator leads connecting to my orange meter here. Just clamp one on each side. Let me get my meter so you can see it. So it's on the K ohm place here, 2K ohm. And so the numbers are in K ohms. And so it's 255.255 K ohms. So 255 ohms. You know, somewhat close to 270. Is that within the 10% tolerance? You'll probably have to calculate that. All right, R2. Measuring R2. Yeah. R2, 297.297, so 297 ohms. Again, on the sheet here, we have measured resistance DMM. This is where you're supposed to be putting these numbers that I'm getting here. All right. 297.297K or 297 ohms. Let's look at R3. Connect it in, same way in between the two alligators. We get 0.092K, so 92 ohms. And finally for R4, 108 ohms. Okay. So even though they have the exact same color coding, they aren't exactly the same size. One's 97, one's 108. Okay, so we measured that. That's, I think, all we, for the smallest resistor, you need to go ahead and do a calculation here. We're going to just use Ohm's law. V equals IR. R is our smallest one. I think that was this one, 97 guy here. R3 was 97, so use V equals IR. You got I, the most I we can have is 0.2. And so we'll find out what the maximum voltage can be that we can get from our power supply without frying a fuse in our meter, because we do not want to change fuses. Okay, next we're going to build on a breadboard. So these are not breadboards that you cut bread on. These are breadboards, they're prototyping boards. They call them solderless breadboards, so we can stick wires in, make connections temporarily, and then take them back apart. And so they look like this on this side, where you stick wires in these holes to connect things. On the back, this one's gotten its coating taken off, or its cover taken off, and we can see little pieces of metal that go across ways here in the middle part, and then they go the long ways on the edge. If I could get one out, I don't know if I can. So I get one of these out, and I don't know if you can see. It's there are a bunch of little clamps, little pinchy clamps that grab wires that are poked in the holes, right? And so all of the ones in this row, then, if you poke them in that hole, that row, they are connected to each other. It's like a node in the circuit. So like I've drawn on here, anything connected in these middle rows this direction will be connected to each other. So if I connect two resistors, one in here and one in here, they are connected. Similarly for all these rows. On the other side, or on the sides, they're connected the long way. Notice there's a gap here and here. Right, they're not connected across that little gap where this, where this center is. But anything in this whole row would be connected, and on this side row would be connected if we plug them in. This is a little bit older version. Here's a newer version. And it has the plus and minus suggested. The board doesn't care what you connect in there, but it's just kind of suggesting maybe this could be the plus for all the power that we're putting in. This will be the minus for all the power we're putting in, and then we can just pull off what we want. Okay, so this is our breadboard down here. Let's see if I can get the focus to go back down there. Kinda, maybe, I don't know if it did. We'll go with it. Okay, so it has this whole list of instructions here. The red lead from the power supply goes to the positive terminal. The red lead from the power supply positive terminal goes to a breadboard plus rail. And so I'm going to just use these little jumper wires here to be able to connect. So we've got the breadboard plus rail. Just this red, we'll just use this side right here. So I'm just going to stick a little wire, just a little piece of wire, so I can get into those little clamps there. And I'm going to take the red from the power supply, and I have long wires here, but this is, you can see the whole wire here, the red from the power supply, and it's going to go to the plus rail. Red is plus on the power supply. So now we have, if I can get it in there, clamped on there. If I would turn the power supply on, this red row here, this row next to the red color, is energized to the plus 5 volts. And let's just go ahead and get another one. All right, let's look at the instructions. It says the black lead connects the power supply negative to the negative breadboard rail. So let's just put it over here a little bit, so because we don't want the positive and negative from the power supply to touch each other. All right, we don't want to short out the power supply. So here we have the negative from the power supply, negative. We're going to connect it to this little wire sticking out so that the breadboard negative, we do not want those to touch each other. Any part of the metal to touch each other. And it seems to want to. See, it's wanting to come here. These touching is a very bad thing. shorting out the power supply. Let's see if I can route it over this way. Something like that. Stay out of the way, wire. Okay, so now we have negative rail here, connects to the green wire, which comes and goes through this black wire to the negative of the power supply. Positive of the power supply comes through this red banana plug cable, alligator clip to this orange wire that connects to the positive rail there. So now all of these places are potential power supply pieces where I can, like my little voltage sources in our circuit, we can connect in and get power. Okay, so that's step 1 and 2. Now, a jumper wire connects a positive rail to a DMM lead. Make sure that the DMM is good and has a good, it's set to read milliamps. All right, so we're gonna not need to measure resistance now. We're gonna go ahead and measure volts on this guy, and this is the one we're gonna use for current. It has these amp reading settings. The 10 amp one, we would have to plug our red lead over here, and it has no fuse. We're gonna go over here to this side because we're reading small currents, and we're gonna just go ahead and turn it to, I don't know, let's start with 20 milliamps. Okay, and so this meter is gonna have to be in series with whatever we're measuring, whatever thing that we're trying to measure the current on. Get my leads. And so in this case, it's going to be a resistor we're going to stick in here. But the instructions say a jumper wire connects the positive DMM rail, positive rail to a DMM lead. So we're going to take, I thought I had another little wire. Here it is. A little yellow wire for the positive rail. And we're going to connect this DMM lead here. Oh, let's go ahead and check that this doesn't have a blown fuse. So if we, to check that it doesn't have a blown fuse, let's actually put it on ohms. And it should, so when we're not connected, it says OL for overload. When we connect them, it should go to a small number because it's reading the resistance of the wire. So 0.1 ohm is reasonable for the resistance of the wire. So I think this one is working. If we have a blown fuse, I don't think it will measure that. Okay, so let's put this back on the 20 milliamp range to start with and see how it works. And we'll connect the red lead. Trying to keep things from touching that shouldn't touch. The red lead to the plus here. We don't want it to touch the minus over there. Okay, hopefully. Let's do this instead. Go over there. So these two are the same point. They can touch each other, but the black and the red should not touch each other. Encourage them to stay apart here. Okay, so this DMM, so that is touching the positive. Number 3, a jumper wire connects an inner row to the other DMM lead. All right, and so let's try a blue wire. We don't have a blue one yet. So one of these inner rows, we're going to connect resistors in here to do the measuring. So let's just stick a wire in there somewhere. And this fatter black one is the negative lead of this DMM. So let's go ahead and connect it to that. Okay. That is number 4. Number 5, a jumper wire connects a negative rail to an inner row of the breadboard. Okay, so now we're going to make a place to stick resistors in the board to measure them, but we got to get a negative connection here. So let's just stick this. The negative rail is the far side. If I put this little jumper, it's connecting the negative rail to this row 14 basically, whereas this one's in row 25. So all these points are connected to each other, all these points are connected to each other, but this wire is not connected to this wire inside the board, right? Remember the rows were going this way. Okay, so now we want to, the resistor we're going to test, we'll start with resistor 1, needs to go in between these 2 points on the breadboard. So we can kind of bend the legs a little. Actually, let's spread this out a little so it doesn't have to bend it so much. So now it goes from 10 to 25. So we're going to stick this guy in here, one leg in there, and one leg in here. So now let's see how so this is our battery or power supply. It's like our voltage source. Comes out of the plus, if we're thinking of current flow, comes out of the plus, flows to this alligator, to the orange wire, to the positive rail, comes out of the positive rail to this yellow wire, through brown meter, that's measuring current. This is our current meter. It goes through the meter, right? So this is a dangerous thing for this meter. It could get us fuse blown if we go too high on the current. But it goes in, comes out the minus, comes into this little blue jumper wire, goes into this row of the breadboard, row 25, comes to the resistor. Resistor doesn't care which side is plus, which is minus, doesn't matter. Comes through the resistor to this other row of the breadboard, row 10, goes from row 10 through this jumper to the negative rail to this alligator, that alligator to the power supply. So we have a closed loop now. If I turn this on, we'll put current through this resistor, which is good, but we also want to measure the voltage. So let's put a couple more little jumpers in here. I don't know. Let's do a little red one. So let's put a little red one in here. We could just clamp onto the resistor, but we're going to want to put different resistors in here. Let's put a little red one there, and a little, I don't know what color this is, purple, brown maybe, over here. And so now this other meter that's on volts, nope, it's on ohms, we want it to be on volts. Let's put it on 20 volts DC. We're doing DC voltage measurements here. And so let's connect the negative to this brown wire and the positive to this red wire. Get on there. Okay, oops. And then it popped out of the board. Let's get it back in the same row. So these are all three in the same row. So they're all touching each other. And these are all three in the same row, and they're all touching each other. Okay, so brown meter measuring the current through my resistor. There shouldn't be any. And the orange meter is measuring the voltage. All right, and so I've got my current knob just turned all the way up, so we're not limiting by current. We're going to control it with the voltage, and we're going to watch the voltage. Well, we're going to watch the current measurement, so this does not go over 0.2. Oh no, it's milliamps, so it doesn't go over 200. It's on the milliamp setting right now, so it can't go over 200. Let's not go over 150 if possible. All right, so I'm going to turn up my voltage knob.